Okay, so once again, I'd like to welcome you to our webinar series, Teaching Statistics Using GeoGebra, with our presenter, Toitdong Fanyamada. She's a lecturer at the Mathematics Department in Cal State Los Angeles. She enjoys building interactive graphical illustrations with GeoGebra to teach statistics, trigonometry, and calculus. She's presented much of her work in conference and in journals. One of her papers was featured on the cover page of the September 2014 AMATIC Journal. She is president-elect of California Mathematics Council Community Colleges South since March 2018. So join me in welcoming Ms. Fanyamada. The views expressed by the presenter are not necessarily the views of AMATIC. Commercial products mentioned are not endorsed by AMATIC. We'd like to thank Alex and McGraw-Hill to support the webinar series. And now I will stop my sharing and turn it over to you.
Good morning, everyone. Thank you for joining me this morning. As Pat introduced, I will share with you how to teach statistics with GeoGebra. So what is GeoGebra? Some of you may be familiar with, some of you maybe not. So this is developed by Margaret Hohenwater for his PhD dissertation. And the GeoGebra is well known with its dynamic graphing tools for geometry, algebra. That's why they cut off the word geometry, the first part, and algebra. That's why they have their name. Many people use this for trig, for calculus, physics, and many more. So why GeoGebra? So GeoGebra have a wonderful statistics tool that you can create from statistical graphs to analyzing data using hypothesis tests, all tests that you have in here. It requires no programming or coding skill at all. It's like basically a big graphing calculator. And then you can see all feature in there. And then you can copy from Excel, from StackCrunch, from SPSS, any software that you can copy over, you can do it, require no. But if you really like programming, then you can do some complicated program if you want to. So I create this little thing right here. So I am a pure math people, so I never volunteer to teach statistics at all. So one year they give it to me, so I have to teach. And then when I come to the classroom, my students come with like more than a dozen different type of calculator, and I don't know how to use it. I don't know how to answer all the manual for my student. And it's tiny small, I cannot see all their work. So that's where the fall. And then I decided I will make a program with Excel. So I saw somebody did that. So I tried to do my Excel, but then I see, why don't I do with GeoGebra? So I know a little bit GeoGebra by then. So I didn't know they have the statistics tools. So that's why these are the first one I did. And then I create the whole set of that. But after, when I tried to do the F-test and the goodness of it, and I stuck, so I researched and I found out the whole thing. I will share with you some of my work today, but most of the time we will use the GeoGebra package. And most of all, it's free. So student, teacher, anybody can use anywhere. You can work offline or online, either one will work. So this is what I like to share with you today. These are tasks here. We're gonna do that part. So the first part, the first two steps, we're gonna do with the GeoGebra app. And from number 3, so I'm gonna use this project here to demonstrate all the part right here. Some of them use my app. So let's start. So if you like to work with me, along with me, then you can go to geogebra.org and then you click on probability link. So from there, we're gonna work online there. But if you decide to watch me, then you can do that. So we can have the video recorded and you can see later, you can work by yourself later. So we're gonna work on these two topics with the app on GeoGebra. So let's do that. So here you go to geogebra.org, and then you're gonna select right here, probability link right here. Okay, so I'm gonna click on this. So you're gonna see something like this. So this one is the normal curve with all the things we do right here. So, you know, when you, after you introduce the, you go over the introduction of statistics, how to take sample, what is good sample, how do you get the, how to read the data, everything. So you're gonna go, the first part you do, you're gonna have them student to do part. So if I have the mean of 100, and then let's say standard deviation 15, and that I will see, you can have your student to do percentile. So, okay, so what the score would be, the percentile would be, let's say 85. So what that would be? So you're gonna click the right-hand side, so it cover right here. So right now 84, so I can cover, I can type over here 85. So I would find out what score would be like, I have percentile 85. So right here I have the point 115 something. So I can have people 116 would be, you know, on the 85 percentile. Or you can do backward. You can say if he or she score 120, then what score, what percentile is she? So you can do that one too. You can cover it right here, 120 right here. So you can have the part, that would be she on the top 9%, like that. Or you can like to say, what is the percentile, what the percent of people score between, people score between, let's say 85 to 115, you can do that. Or you can do 85 to 100. 805. So what is that? What is the score would be? So they're going to give you the percent over here that you can do that part. Another part that you teach student, when you click on here, you have a lot of statistics curve that you hear. This is student, that means T curve, and then you have chi-square, F, exponential, everything. But I'm going to go to show the binomial because this one we did a lot with them. So for example, you're gonna have your student roll a die 40 times. So I can put over here 40 times, and you ask them. So with the probability to get a one, a number one, that would be 1/6. You can type directly here 1/6 directly like that. You can have that part right there, and over here it lists for you all the percentage have no 1, 2 ones, 3 ones, and so on right here. So let's say your student come up with like 40, and your student come up with like, let's say 9, number one. So is that okay? So that will here we have 9%, so that's okay. It's kind of low, but it's okay. And then same thing, if we look at up here, so the higher percent we have that here would be 0.16 right here. So if they have this part right here, that would be the highest one, because 40 divided by 6, so you have closer to 6 you have there. And then you can do the middle of how many right here. I can change over here. You say, what is the chance that I will have somewhere from 4 to 10 number one in the 4 rows? So what does that would be? So we can do that part too. So you can use this one to test student without like compute. All this one would take student a long time to do all of this, but this app can allow students to do this part really well. So that is the first part that we did right here. So now I'm gonna move on to the second part. So locating midpoint of a segment would be, it posts a lot in many statistics textbook, but we will use it using the app. The reason, because on the textbook they say have the student draw a segment and ask people to estimate the midpoint, and all the thing is measuring, and they don't have the right equipment to do it, so error a lot. But this one will allow us to do easier with online app here. So we're gonna go to the my website, fanyamada.whipley.com, and then we're gonna locate a select conference, and then from that we're gonna do locating midpoint project. So in this project we answer all the questions. We gotta go through all the testing right here. So let's do that. So go to fanyamada.whipley.com, and you select on conference. So where I prepare all the link, the file for the talk today. So conference. So right here, you see locating midpoint right here. So you're gonna click on this. So if you have a phone, you can follow this for fun. If we can get data of all 40 of us here today, compared with my student, it would be fun to do that too. So let's do the part here. Click on this. So here's the app. So take the segment AB in horizontal right here. And you're gonna drag the point E. Where do you think that midpoint of AB would be? You put on there. So I put mine right here. And same thing over here, we're gonna do with the slang. So we like to see is that people do better on the horizontal or the slang. That's one thing to do. And another question to pose over here is that people can locate the midpoint correctly. So there are two main questions we can have here. But if we have 40 of us today, we can compare, is that we as a instructor, college instructor, do better than my student? We can do that comparison too. So after you put this one here, you click submit. So it will tell you the error that from your midpoint, you think of your midpoint to the actual midpoint would be. So I'm off for the AB, I'm off about it, 0.023 inches, and this one would be 0.024. So that's what I have over here. So you're gonna go down here, you're gonna copy this number in here, and you enter. So my first one would be 0.023. And then my second one would be 0.024. And then you go down here, you submit, and we will see here. So I'm gonna pause for a second, and then we'll see if you can see the part. Yeah.
Okay, so if anyone's having trouble following along, this would be a good time if you want to use the chat window to let us know where you're having trouble, so we can talk as many of you through it as you can. And we've got 36 participants, so we didn't quite hit 40.
Okay, so that's good.
And one of the 36 is your second computer up there, so. So well, we should get, hopefully we'll get quite a bit of numbers.
Okay. So once you get that back, you go back to my website conference, fanyamada.com. I mean, fanyamada.whipley.com and select conference. We will click on locating midpoint data. So we're going to click on this one. And then you see all the data. So the top part is my student doing the project, my summer student. So they get it here. We had a lot before, but I have to erase to have this one. So let's see how many of you do this today. So we have a lot. Okay, so we have, I think this good size is enough for you. Any of you try to do that part right here? So you have all the data. Yeah. So on over here, you see 3 digits. So that's how I set up on Excel. But on GeoGebra, you may see only 2. So however, all the data will copy over. So they just show you 2 digits, 2 decimal, but they have everything in here. Right. So we're gonna do, so a couple more. So we have from here 61 down to 79. So we have 18 people. 19 people. Okay, so we can do, we can copy this data right here. So let's do like this first. So I'm gonna copy, we're gonna copy from what we do here, our group, we copy from here to here. Yeah. We copy this. So you're gonna do Control-C, or you can use copy from here, either way it works. So I'm gonna use Control-C. So I copy this, and you go back to GeoGebra tool right here. You click on spreadsheet right here. Click on this. And then you're gonna paste the data right here. So right now I have 19 people doing this one. So now you notice some zero right here because they just show you 2 decimal. This one you can reset when you have your screen. You can reset it, go to the offline. You can download, you can click on view and then set up to show how many decimal you want to. But in here, we just leave it for now. Okay, so first I would like to see is there correlation between the locating horizontal line segment and locating the slant segment. So we're gonna do right here, we're gonna highlight these. And then we're gonna click on this histogram symbol right here. Select 2 variable regression analysis. So click on this. Then you will see the graph of what we do today. So it kind of look like here we look like we have no correlation at all. But take a look, matter right here. So we have this one. Let you, this sigma symbol that here, that where you see all the things that you see right here. So you see the mean of the horizontal, which is the bottom, and the mean, the y, which means the slant, and standard deviation for each column. And this is what we're looking for, the relationship, correlation right here. So we have it like 0.01, so very weak correlation we see there. Now something cool about this feature here, so you see that I have, look like we have this one right here, look like a outlier. So let's take off this one, see what happened. So this one from 0.4 something and to over here 0.23 something. So I'm gonna locate that one. I'm gonna remove that, see what happened. So let's see where is that would be 0.04 something. So maybe look like this one right here. Let me move this one bigger so you can see. Okay. So for 0.04 something and 0.02 something, so that look like this point. Yeah, look like this point right here, number 15. So let me uncheck 0.15. You will see this point will be removed and your R will be recalculated. You will see that's one. So let me remove that. So you see now your R become negative as what you think that before. So you see, go down here instead of positive you see before. You can put it back to see that part. So if you're, when you do this one, you have a lot of outlier, you can do this one to quick calculation over here. Now let's see, you want to see, let's say, well, this is not strong correlation, but let's say we try to see it, the linear regression model, what does that look like? So it gives us the line right here, that you see that part right here. And then if you want to see, let's say I'm gonna use this model. So I would like to see if my horizontal guess would be 0.012, so what in my y would be, so it's gonna show it to me right here, right away. So you can have a task for your student, do all of this within a click, and then you have everything really fast. So that's about the correlation. So now we're gonna copy, you still have that copy on your data. So we're gonna do another test that you see right here. The next one, we're gonna do the t-test. So we like to see if we as instructor, we can check if that's this, we can locate the midpoint correctly. That means the no error, that means the mean of this one should be 0. So we're gonna use that data to do that part. You can do it right on here, right? So you collect this one right here, and you click on this. So one variable analysis, then you will have the histogram of this side only. So from here, if you click on this, you will see, again, the mean, the point you have it here, the standard deviation, minimum, Q1, median, all that pi number data you have here. So now we're gonna do the test. So we're gonna do the t-test for the mean. We can see if this one is, say that we can locate the midpoint correctly. So over here, the no would be mu equals 0. And the alternative hypothesis would be mu not equal 0. So you see right here, P equals 0. So P equals 0, that means we reject the node. That means we cannot locate midpoint correctly because we have some error in there. So have on here. However, you can use this one in my feature, the app that I created. So it have something for you to see. So let's go to my website again. And then you click on the GeoGebra commands and tests for statistics right here. Here you see all the GeoGebra command for statistics. I type everything in here. And some of them I created, so you can do it. But some of them is from the app. So let's try to do the t-test for a mean right here, the one I created. You will see why I would like to introduce to you this one. So this is the app that I created before I know that there is the statistics package in GeoGebra. So I still use this one with my student because it has feature graph on that, so easy for my student to see. So you're gonna paste the data that we do that later. So we have 2 column data, but we give you the first column only, right here. So you select spreadsheet data. So here we have 19 people. So we're gonna put over here 19. We enter in here 19. And this one, it only, it calculates only the first column, the column A right here only. I'm sorry, this one should be 19. 19. So it computes the standard deviation for you right here. And the sample mean right here. If you compare to the node we had before, it should be the same. And I like to see if the mean 0 is good. So I put right here. And then my alpha over here would be, let's say 0.05. Have right here. And we're gonna use 2 tests because we see the claim it would be mu equals 0. That means we have no error. So we have in here. So again, you see, this one you see more than that. You see the p-value, which you will see on the other screen. The one that we're going to see here, that means the t-value. So 8 point something is right here. So in the red region, so it had the red region right here. So we reject HO and also have the confidence interval. We say 0, 0 not in here. So again, we're going to reject the HO, which is the mean it equals 0. So we say that we have error when we locate the midpoint by the part right here. So I like the feature. I show my student on this part right here. So it helps them to see things better. So for the t-test, z-test, all this one here, I use my own app. So you can find all my app. I go to the file earlier, the command file. You could find all of them. You can do that part. So now let's try to do some. Now we try to compare. Okay, so is that we can locate the midpoint better on the horizontal or the slant. So let's do the t-test for the 2 mean. So again, I use my app, but you can use the GeoGebra app they have in there too. So they don't have the picture like I do, and they don't have all 3 data we have in there. So I'm gonna do it here. So I'm gonna do the spreadsheet. I'm gonna paste my data in here. So that would be 15 data, I paste in here. Right? So I do 19, over there have more, so I'm happy. So for this one, you can have like the sample 1 have different number of data than the sample 2, you can do that. But this case, we have all the same 19, so we can do that part, 19. And then we can do over here, 19. Right. So we have right here. So my student think that horizontal is easier than slant height, than slant. So that means we do the left-tail because easier, that means you have less error. So you can have that part. And then you have all the other thing in there. And then over here, you will see your, let me have, this 0.05, that's good. So we have T a 0.1. So 0.1, that means bigger, I'm sorry, the p-value is 0.5. So bigger than 0.05. So therefore, we do not reject HO. So we say that there are no difference between locating the midpoint of the the horizontal or the slant. There are no difference than what we have here. So some people say, oh, maybe it's not less, but maybe it's equal. So you can use two tails. So again, 0.8 again. There is no difference. They are both of them the same. So regardless, you have up and down the same. So now we can compare with my students. So we have 19 over here. So like go back to copy the data from my student. Let's say we copy my student right here. So we're going to do the horizontal of my student, compare with what we do today. So I'm going to copy like 20, maybe 30 students, and then compare with us. So we have a small group participate in here, but let's see how does that come out. So I'm going to put this one on the column B. Right. So you see the data we have over here. So the first one is 19, but the second one we have over here, that would be, let's see. Second one over here we have, that would be 20, that was this? 30, I say 30, okay. 30, so I got to change this one to 30. So it will calculate that for me too, 30. Okay, so we think that we do better than our student, and they say it claimed that's the same. We're not better than my student. So let's see, it's same, that means we less than. So again, it's the same. So we and our student, my college student, would be the same. But my student found that they do with the elementary student, they do see the difference between elementary student and the college student. They have that part. So that's fun for t-test for 2 sample. We see there. So now we're gonna go back to my website again. Okay, back to my website. Conference, we're gonna go to open this file right here. Problem for hypothesis testing, right there, this one. So I gotta use problem from this open textbook and one problem from the Star Trek website to do the part. So let's do the first one, z-test for one proportion. So for the first one over here, so the claim will say that the claim would be P would be bigger than 0.22, right? And then the sample will be 500, and then 125 of them breastfeeding the infant. So we're going to use this one to do t-test. So you can use the app from GeoGebra right here. You can use that part. This one we have here. You click on statistics, and over here you're going to do the z-test for proportion right here. You can do that. So you enter over here P, we think it may be 0.22. And then over here we will say is would be greater. And success would be 125. And then the people enjoy over here would be 500. Enter. And then you see the p-value would be 0.1. That would be we do not reject HO, so we can have it there. Or you can use my app. So again, my app, it have more feature. It have picture in there for students to see, and have other value like the Z value and the critical values and everything you can have in there too. The shape. And let's see, how do we do it? Yeah. And then you can do the z-test for 2 sample too. Z-test for 2 proportion too. So let's do the following problem. This problem right here. We're going to do the second problem, sorry. This problem right here. Hypothesis testing for 2 populations. So they said, is that the husband cheat on the wife more than the wife cheat on the husband? So these are the 2 groups here. So they survey 1,000 husbands and find out that 231 had cheated on their wives. And another group of 1,200 randomly selected wife and 176 cheat on the husband. So due data proportion show that the proportion of husbands who cheat on wife are greater than the wife cheat on husband. and they yield a 5% test interval. So we can use this data to do this test too. So we do z-test for 2 proportion. So the first one would be the husband that 231. And then the interview people 1,000. And then the second one is for the wife, that would be 176. And then the N would be 1,200. And then they say a husband cheat more, so that means greater, and the null hypothesis would be equal. So right here. So you see, again, you see the p-value is 0. That means we reject the nulls. That's the data support the claim that the husband cheats on the wife more than the wife cheats on the husband. So that's the z-test for 2 proportion. And then now go down to chi-square test. So in here, they have chi-square test too. So right here, it looks like this. So we're going to do on this problem right here, the third problem like this. So they have the autism, breastfeeding, with no breastfeeding at all, less than 2 months, and 2 to 6 months, and more than 6 months. So the claim to see that is that the breastfeeding, are they independent or not? So the SO would be the breastfeeding, yes or no, this would be independent. And the alternative would be dependent. So this is a question they ask for here. So that breastfeeding and autism are independent. So this side and this side would be independent or dependent. So that we gonna do the test right here. So I don't waste the time to enter on the data. So I create the app right here ready for you to see. So if you click on the app, you will see all the data I added in here for you. But if you can do it by hand, you can go to this site again. So you can, sorry. Okay, so you can go to this site again right here. So you can, over here, we want to have like 2 columns. I'm sorry, 2 rows. So you can have it 2 rows. And then over here would be 4 columns. You increasing. And you give the name for each of them right here. So that's why you will have the the file that I'm doing right here for you to see. You see it right here. Yes, so you see, I already entered everything for you. So after you enter all this number on this cell right here, you will see the number automatically add in the bottom for you, that the total of each column right here. So they don't have the row total on the side for you. However, they do have the compute everything for you, like column percentage. That means over here, what is the percentage of 241 out of 261? So everything computer here. Or you want to do the computer row, even though they don't have the total of the row for you, but they can compute it. 241 out of over here will be 818 would be the answer, would be right here. Or you can see the expected count. All of them will be over here. You can ask your student compute the part, but they can use this app here to have the number right away. And the one that takes a student a long time to do it, compute the chi-square, with a long formula, but here is compute ready for you too. And then again, we look at the test right here. So what we're looking for, the p-value, the 0.01. So it's less than 0.05, which we usually use. So that would be, we will reject HO. That means the breastfeeding and autism are independent. So we reject that. So that means we support the other idea. That meaning the breastfeeding and autism are likely dependent. So that must be the connection between the time breastfeeding and autism we have in there. And then another topic we do is chi-square good net effect. So that could be this problem right here. Oh, I'm sorry. Yeah, this problem right here, I picked it from Star Trek website. So it had the feature right here. So it say the toy company printed baseball card. So they have 30%, they claim that they have 30% card would be rookie and 60% veteran, but not all-star, and then 10% veterans all-stars. And some people randomly choose 100 card and come out with this idea, with number right here. So this one is that consistent with the company claim. So that's what good net of fit. So we claim that the company claim right here. This is what we test. Is this true for that part, good net of fit? So we're gonna test this one here. So we go over here. We're gonna choose good net of fit, and then you can type it in the data over here. So I'm gonna choose over here, I'm gonna choose 3 rows because I have 3 names. So you can type over here, you can type in, this one would be rookie. And then this one, I just have a veteran right here, veteran. And this one would be all-star. I did do like this, all-star. So you can type it like this. And then you're gonna have the observed count. So over here, we said they put 100 card and 50 are rookies and 45 are veterans and 5 all-star. And then expected count that they say 30% of 100, that would be 30. And then this one would be 60% of 100, that's 60. And this one will be 10. So we like to see what happened over here. So again, the p-value is too small. So therefore we reject HO. That means their claim, the company claim is, we will not support that claim. So you can see the percentage of column they compute in here for you too. So have everything right here. So very nice feature. You can have your student do all this problem, a lot of problem during test by using this app right here. And the last item we do is ANOVA, which we in community college, we hardly cover this topic at all. But if you teach like advanced calculus, advanced statistics, the second year, then maybe you can cover this part. So we're gonna do ANOVA. So ANOVA, we're gonna do this problem right here, is in the textbook too. We're gonna do very last problem, this ANOVA right here. So if you can go to the website and then follow through, you can see the whole thing. Again, a lot of typing, so I'm gonna use this one right here to already build for you, so you can use this part. So basically, I copy the data, so make it ready. So if you click on this website, you see the data I already built it for you right here. So in this problem that we want to see is that all the mean here, all the breast cancer, they have the same mean or not. That is HO. And the alternative hypotheses say that there are at least 2 of them don't have the same mean. So that's what we're testing over here. So we're gonna highlight all of this. And then you're gonna click on this part right here. And you choose multiple variable analysis, click on this. Then you see all this box right here is happy for you right here, over there. Okay, so we're gonna click on this sigma symbol. Whenever you want to get the statistics values, anything like that, you can click on the sigma symbol. So it show you for you right here, it show you a lot. So I'm gonna move this one up so you can see. So see how many number in the survey for each category, and the mean, how many is population standard deviation, the sample standard deviation, and the fine number data right here. So we're going to do the ANOVA. We see it's all the mean are the same. It doesn't look the same right here, all the sample, but we like to see in general, can we use this one to test that? So we use ANOVA right here. So it's right here, it gives us the degree of freedom, the SS, the MS, everything. But again, we're looking for the p-value. The F value right here, the p-value right here. So p-value here is less than 0.05. So therefore, we reject the HO, which all the mean are the same. So we don't think that would be, we would not support that one. That means there are at least two of them. The mean is not the same. And all the X right here, that's all the outlier for each type of data you have in there. So it helps you to see a lot of things right there. So I cover all the topic. So if you go to my website, you go to Fanyamada. Yeah. If you go to fanyamada.weebly.com and you click on teaching and you select statistics. So over here, I have all the topic. I use GeoGebra for everything. So you can, if you teach other topic, you can click on here. You see other topics, project and activity in here. But we're going to go to statistics right here. And then you go down. So these are other topic, other project that I have my student do. So the top two is the project that I wrote for this. The other three I copy from other people. So you'll be able to do that part. These are statistics apps, so you can have fun time to do with your student in classroom. So I show you this one I copied from somebody else. So they call it Schoolopoly. Is their file or a fair or balance? So they have like several companies right here. They claim that they produce the correct numbers of dye they have in there, and then their dye is fair. So you can do the testing over here. You do 100, or you can do is 1,000 up to 1,000. That's what they said here, and you enter. That will see different things. You see right here. You can do the other company. See, that's the one here. I have my student do this. Say which one is fair dyes they have here. Again, they use GeoGebra to build this one. It's kind of fancy. If you like to do this, so you can build your own thing you have there. That's one thing I would like you to do today. Introduce with you today. That is this one right here. I didn't write a project yet. The one is red light reaction. So this one right here is nowadays people are doing multitask when they are driving, especially with their phone. So they can check the messages, or they can text people, or they can view all their media out there. So when we drive in a car, so we see if the car in front it have the red light, and then we gotta hit the brake. That's what we do. So let's do the test drive here first. So you start, and then whenever you see the green light here turning red, and then you're gonna click a brake. That means you apply the brake. See how fast you are. Over here would be. So I'm gonna have to start, and then I hit brake. So I am 1.88 seconds behind after the brake. So you can do that. So you have all the correct. So you use all the data here, and then we calculate what is the safe distance between two cars when you drive in there. So that's the regular mode. That's what the government come up with, the suggestion, recommendation, the distance between two cars. But now, let's say if you drive in the car and then you using the phone, you glance at your phone, and then is that a distraction? Is that safe for you to drive? So I would like to propose something, kind of, it's not the real life. We cannot experiment that in real life. It's hard, but we can do with this app. Right here, this is what I do right here, app number 2. So you drive in the car, same thing too. And whenever you see the red line, then you're gonna hit the brake. So let's do that. But this one distraction come up. So you ready to start? Okay. So I see distraction come up right here. And then, so to see my distraction be 3 seconds something after. So earlier it's 1 second, it's now 3 seconds. So I missed it almost like 2 seconds with distraction. So what is yours? So can you, I'm thinking to use this one as a way to do some sort of survey experiment to see how much distraction you get. Is that safe So when you drive with the distance between two cars, how much, and when you have your phone on, so then how close will we get to the crash if you crash the front car, that kind of thing. So I didn't write this one down yet, but if any of you like to work with me on this project, please let me know. So you can email me, tfanyamada@weebly.com at the end, right here. Or, I'm sorry, you can email me tfanya3@calsetla.edu. So then we can work together with the project. So that's it, my sharing today. So I hope that some of you sharing that you have your school will be until like 2 weeks or 3 weeks later, some of you on September. So you can use all the ReadyView app in there, this app right here, or this project right here, ready for you to use. So I already detailed the lefty-righty project and the midpoint project. I already write down step by step what to do, how many points do you need to do the group project, but individual credit. So you can use that one. So here the first, the lefty-righty project right here, and the midpoint project right here. So you can use for your own classroom later, or you can use the other 3 that I copy from other people for your classroom. So thank you. So if you have any question, you can let me know, so I try to answer.
Okay, thank you. We've still got about 10 minutes left. There was one question during the webinar which seemed more of a how to work the statistics problem rather than maybe the software. Ming, if I'm understanding that right, I think that was your question. So maybe we'll see if there's any software GeoGebra questions first, and then we can come back and answer that. So if you have any questions for Ms. Fanyamada, if you want to enter those in the chat room, or if you just want to thank her for her time. Before everyone leaves, let me share a few final comments. I'm going to get control back. Okay, if you are, where to go? Okay, so if you are not a member of AMATIC, if you're one of our participants from the ASA, we've got a link here to join. We also are on Facebook, AMATIC. If you are a member or not and want to join our Facebook page so you can keep up with what we have. We do have our national conference coming up in November in Milwaukee, and then next year, Spokane. We also have other webinars coming up and traveling workshops. We are looking for a professional development coordinator. So if anyone has professional development experience or is interested in getting a position through AMATIC, you can go to the website, amatic.org. The follow-up email to this webinar will have some more information about this position. Within a week or two, this recording for this webinar will be posted at AMATIC, the link there, or you can go to AMATIC and look under the webinar section. And then if you would please take a couple minutes to evaluate our presenter today. We've got the QR code that will take you directly to it, or we have a link here. And again, this will be, if you don't get that in the next few minutes, this PowerPoint will be sent out in the next couple days to all those who have registered. So let me stop sharing. And just say, are there any questions? Let's see, I think we got some. Let me scroll back up. Okay, where did we start the questions at? Okay. Where can I see the recorded video? As soon as the webinar ends, I will download the video and send it to George Hurlbert to post on AMATIC, depending on how quickly he can get to it. It'll be on the AMATIC website, hopefully within another week or two. But again, the follow-up email to those who signed up will will be sent out when that video has been uploaded.
Can I have some? Can I answer some of the questions that you
Yes,
posted
yes.
here?
Let's see.
So I screen through the list.
Okay. So here's one. Is there a reliable test mode for GeoGebra?
That's the one thing that people ask. How do you? Where do you get the? What is that? I'm sorry. Is there a reliable test mode for GeoGebra? That means you can build your own, and you go over there, you can do it. So there is, you just do it your way. I mean, you try it and then see the work.
I think the question is, if you have the students use GeoGebra to do the calculations,
that thing.
Then on a test, then what do they do on the test?
Yeah, because this GeoGebra can work with any data, so I don't mind they do whatever they want to, because I'm gonna give the number and then we're gonna do the time. So it just you just go. But I saw people using myopenmath.com, so they build several GeoGebra tests in there. So they say it's good. I didn't try that one. But my student, because I give the data from me, so they cannot have it on internet. And if you have the classroom set, then you can monitor it really well. Another question, what would be a good resource to learn to create a GeoGebra app? So you can go to GeoGebra forum. They have a lot of things for you to do. But for me, and for my experience, I just write it and then see if it work. If not work, then I go ask the forum. I ask the people in there, they help me. You can try, and if you have a question, then you can email me so I can answer for you the part. And let me see.
Do you let, when you give exams, do you let the students use GeoGebra?
Yes, I have my students use GeoGebra. So my question is really, it's like real problems. Like give them the raw data and they work out, they do every single step. So, and the number, because they can work with anything, so I can post the new data there.
Does that answer the question about the exam mode? I think we had a couple people asking about that. Or did that answer your question, or do you still have further questions about test mode? And while we're doing that, if you want to give your announcement for the upcoming conference.
I have one thing. As a CMCQ South, we in California, we have a conference in October 12th. So if you are interested to present at our conference, so submit your proposal right now. And if you like to go to our conference in the fall, it will be in Newport Beach. So the campus side look into the beach, very nice one. So I invite you all to come.
Okay, I just posted the link to the survey again in the chat area. And so we got a question. Do your students have full access to the internet when they're doing your exams?
You don't have to. The student can download the app. You can work offline too. So, but I give my student data ready, so they can copy from the Excel sheet, or I email them the data.
Okay. We got a question about the conference details. Did you have specific questions about the details, or is there a link maybe you could post to the conference?
Yeah, the conference. Let me go to the website.
And while she's doing that, we've got a link in the chat that gives more information about the exam mode.
Yeah, it could be CMCQ 3 south.org. Or you can go to my website and you click on that, you will see the CMCQ in there too. Again, the exam mode, I don't have anything for my student because I give my own data. So they cannot search on internet. They cannot have the problem right away because I write it my own. So they cannot search for that. So you can you can make up any fancy data, or you can copy right after the latest data you can post in there. So the student don't have that part.
Are there any other questions? Okay, is there anything preventing them to email the data or questions to a tutor?
Yeah, you have a time. You have the time limit. I have my time limit in the test. So I think is if you use the school have the if the school have the computer, then you can monitor from that. But for those of you who teach online, you still have time limit for the test, right? So the question you write it. So if the tutor not familiar with this one, then they cannot do the part. Yeah, but I think it's hard to teaching online to monitor that part, teaching online, so kind of hard to do.
Yeah, I think we all have that problem in many different formats. Okay, are other questions? We're getting close to our hour time. Okay, well, if there are no other questions, let's thank our presenter again. If you think of questions after the webinar ends, then feel free to email me, and I'll get them. I'll make sure she gets them. Thank you for attending. Good luck with your fall semesters that are coming up, and have a good semester. Hope we'll see you all at future webinars or in Milwaukee in November.
Yeah, thank you to all, and then let me know if you have any questions. Email me. Thank you.
And I'm going to stop the recording.